Welcome to the Algebra final review. This video and the next one are going to go over Standard 2, and we're going to break it into two groups. On the first one, we're going to talk about solving and checking equations and writing and using rules or equations. And on the second one, we're going to go into solving systems of equations, and particularly showing the three algebraic ways that we can work on it. So let's go ahead and get started. Okay, remember that when we're solving an equation or an expression, that there's typically three different kinds of answers we can get. We can get x equal to a number, for example, x equals 5 or x equals 3. In this case, there is one solution, or maybe if it's a quadratic, there will be two solutions. Okay, we can get a number equal to a number. The variable is completely gone. Examples are 0 equals 0. Or the variable can still be there, like 2x equals 2x, 3 equals 3. When we have a situation where we see exactly the same thing on both sides, we know that any number we put in for x is going to work. The way we say that mathematically is we have an infinite set of solutions. Okay? We do have times when, as we're solving, we'll get different numbers that just don't make sense. For example, we'll get to the very end, the variable's gone, and it'll say 0 equals 4, or 5 equals -5, or 4 equals 2. When we get this kind of a situation, it doesn't make sense, and so we say we have no solution. Okay, now, remember, let's see. So here's an example. Let's go over this one from your review sheet. Let's see what kind of an answer we get here. The first step we're going to do is we're going to simplify each side independently. If I do this, these two will combine on this side. I don't need to change their signs because I'm not changing the side. So 17 and positive 4 is positive 21. So I'm going to say this side is now 21 minus 6x. On this side, I have this x term and this x term that can combine. So this side will become negative 6x plus 21. Now, as I go to solve, I'm going to get my x's over here, and my constants over here. So plus 6x plus 6x. Well, something interesting happens. Negative 6 and positive 6 make 0, but they're the same on this side. Same situation on this side, so it's also going to equal 0. So I'm left with 21 equals 21. This is one of those special cases. The variable has disappeared, and so I'm going to say that it has infinite solutions. And a more basic way to say it is any number for x works. Okay. Here's the next one. A little bit trickier. I don't have my calculator out, so let's hope we don't make a mistake. I'm going to pull my x's to the same side. We're already simplified on each side. Okay, so subtract 0.75x from this side, subtract 0.75x from that side. I know that that is 0. Let's see, 10, 11, 1.10x. So I've got 14 minus 1.10x, or 1.1x for some of you who've done this already, equals 3. Now I'm going to move my constant over. I get negative 1.10, oh, that's 0, x equals negative 11. I'm going to divide both sides by the power, not power, but by the number on the variable. In this case, the coefficient of the variable, so 1.10. And I'm going to get x equals 10. Now, I didn't do this on the last one, but on this one, when we get a solution, we can check it. And here is how we are going to check it. I'm going to write the original problem down. And I'm going to plug x equals 10. Remember, another word for equal is. X is 10. So the x here is 10. The x here is 10. So this is going to be 14 minus 0.35 times 10, because that's what x is. 0.75 times 10, because that's what x is, plus 3. Let's see what that gives us. 14 minus 3.5 should equal 7.5 plus 3. Now, I know 7.5 plus 3 is 10.5, and that is going to equal 10.5 also. Now this was checking it. So since this was checking it, I do expect to get the same number on both sides. It doesn't imply infinite solutions because I'm already checking an individual solution. Okay. That, I think, oh, there was one more. This was writing a rule, and I didn't really have enough space to write it and do it, so you're going to have to run off your paper. But one of the things that helps when you're trying to write a rule is to start by defining variables. The story goes here that Noel and Tanya like to make latkes, or potato pancakes, for their friends. They can make 12 latkes in 10 minutes. So, I know this much. They can make 12 in 10 minutes. Now, I'm going to define just L is going to be, L is the number of latkes, and M is the number of minutes. Okay? And let's see if I can write a rule that tells me how many I can do. First, I'm going to try to figure out, 10 minutes is kind of an unusual unit. I think I'm going to try to figure out how many latkes they can make in 1 minute. So if I take 12 and divide it by 10, I'm going to get 1.2. That's 1.2 latkes a minute. That makes it a little easier to write a rule, because I can say the number of latkes will equal 1.2 times the number of minutes, because that's how many they make each minute. Okay, I can use that in my two problems here. One of them says, okay, here's the question. If they, how long will it take them to make 200 latkes? And so I know the L this time. The L this time is 200. So I'm trying to find the M. So I'm just going to plug it in. 200 equals 1.2 M. Oh, I can solve this by just dividing both sides by 1.2. That'll put the M by itself. And if I do that, I'm going to get, as I said, I don't have a calculator, so you get to see me do a little bit of long division real quick. So 200 divided by 1.2. Move the decimal. Okay. If you do not know how to do long division, that's fine. I just don't have a calculator right now, and so I've got to do it this way. 8, bring down 0. 6 times 12 is 72. That is 80. 6 times 12 is 72. Remainder of 8. So it looks like about 167 minutes. Okay. They ask you to continue the problem and do it backwards. This time, they say how many can they make in an hour? Well, that's easy now that we've written a rule. If L equals 1.2 M, and we will have 1 hour, that's 60 minutes. So all I have to do is put 60 right there. 1.2 times 60. That's one of the advantages of using a unit rate. And see, 1.2 times 60 And that'll give me 72. That's also confirmed another way.